What if the universe doesn't just stretch far beyond what we can see, but literally never ends? No outer wall, no cosmic boundary, no final edge where space suddenly stops, just endless reality in every direction. Tonight, we're diving deep into one of the most mind-bending ideas in cosmology, the infinite universe theory. Close your eyes for a second and imagine this. You're floating in space, you pass the moon, you pass Mars, you drift beyond the solar system, past the Kuiper belt, beyond the Oort cloud. You leave the Milky Way behind. You cross galaxy clusters, not superclusters. You travel for billions of years at the speed of light. Do you ever hit a wall? According to modern physics, probably not. Right now, scientists estimate the observable universe is about 93 billion light years across. That's the region whose light has had enough time to reach us since the Big Bang, about 13.8 billion years ago. But observable does not mean total. It simply means that's how far light has traveled to us so far. And here's the key idea. The universe might be much larger than what we can observe. In fact, it could be infinite. To understand this, we need to go back to the beginning. Around 13.8 billion years ago, the universe began in what we call the Big Bang. But the Big Bang wasn't an explosion in space. It was an expansion of space itself. There was no center, there was no outside. Every point expanded away from every other point. But something even stranger happened right after the beginning. In the tiniest fraction of a second, less than a trillionth of a second, the universe underwent a period called cosmic inflation. Proposed by physicist Alan Guth in 1980, inflation suggests that space expanded faster than the speed of light for an incredibly brief moment. Not matter moving through space faster than light, but space itself stretching. Imagine drawing two dots on a balloon. When you inflate the balloon, the dots move apart, not because they're traveling across the surface, but because the surface itself is expanding. Now here's the critical question. Did inflation stop everywhere? Some models suggest it did not. In certain versions of inflation theory, called eternal inflation, space continues expanding in some regions even today. That means our observable universe might just be one small patch in a vastly larger, possibly infinite, cosmic structure. But how do we know if the universe is infinite? We look at geometry. The shape of the universe tells us about its size. There are three possible geometries allowed by Einstein's general relativity. Positively curved like a sphere, negatively curved like a saddle, or flat like a plane. Measurements from missions like the Planck satellite show that the universe appears incredibly flat, not curved noticeably in either direction. And here's the fascinating part. A perfectly flat universe can be infinite. If space has zero curvature, it can extend forever in all directions. No edge, no boundary, just endless expansion. Now pause and think about what that really means. If the universe is infinite, then the amount of matter inside it is also infinite. And if matter is distributed randomly, but according to physical laws, then patterns must eventually repeat. That's not science fiction, that's mathematics. In an infinite space with a finite number of possible particle arrangements in a given volume, those arrangements must repeat somewhere. In fact, infinitely many times. So somewhere, far beyond our observable horizon, there could be another Earth, another solar system identical to ours, another Milky Way, and possibly another version of you. Same memories, same voice, watching this same video, but here's where it gets even more intense. There could also be versions where tiny differences occurred. A world where dinosaurs never went extinct, a world where humanity never evolved, a world where you made one different choice, and your entire life changed. And these aren't fantasy timelines from movies, they are logical consequences of infinity. Now let's go deeper. Infinity doesn't just challenge our imagination, it challenges physics itself. If the universe is infinite, then statistically, every physically possible event must happen somewhere. That includes rare quantum events, extremely unlikely combinations of atoms, even structures forming purely by chance. There's a famous thought experiment called the Boltzmann brain paradox. It suggests that in an infinite universe, random fluctuations could assemble a fully conscious brain out of chaos, complete with false memories, floating in empty space. If infinity exists, then even the absurd becomes inevitable. But maybe the universe isn't infinite in space. Maybe it's finite, but unbounded. Imagine walking on the surface of Earth. You can travel forever without falling off an edge. The surface is finite in area, but it has no boundary. If the universe is shaped like a higher dimensional sphere, you could travel in one direction forever and eventually return to your starting point. No edge, no border, just curvature. So which is it? Infinite and flat, or finite but curved? Current data leans toward flatness, but the precision isn't perfect. The universe could be so large that any curvature is too small for us to detect. Now let's talk about time. If space is infinite, what about time? According to our best models, the universe is expanding. And that expansion is accelerating due to something called dark energy. Galaxies are drifting apart faster and faster. Billions of years from now, distant galaxies will disappear beyond our cosmic horizon. Trillions of years from now, stars will burn out. Eventually, the universe may reach a state called heat death. Maximum entropy. No usable energy, no stars, no light, just cold, dark expansion. But in an infinite universe, even heat death might not be the end. Quantum mechanics allows for random fluctuations. Given infinite time and infinite space, tiny fluctuations could eventually create new regions of high energy density. New Big Bang-like events, new universes born from the old. Eternal cycles within infinite reality. And then comes the multiverse idea. In eternal inflation models, our universe might just be one bubble in a vast cosmic foam. Other bubbles could have different physical constants, different strengths of gravity, different laws of physics. Some universes might collapse instantly. Some might never form stars. Some might be completely unrecognizable. If that's true, infinity isn't just about size. It's about variation. Now step back for a moment. Why does this matter? Because infinity changes our place in reality. If the universe is finite and unique, then everything that exists is rare beyond imagination. But if the universe is infinite, then nothing that can happen happens only once. Somewhere, infinitely far away, civilizations rise and fall. Stars explode, life begins. Stories unfold, again and again. But here's the emotional twist. Even if duplicates exist, this moment, your awareness right now, is still singular from your perspective. You will never experience the other versions. You will never meet them. Infinity doesn't reduce your significance. It reframes it. You are a local miracle in an endless structure. And perhaps that's even more powerful. Now imagine trying to actually prove infinity. We can't travel beyond the observable universe. We can't see past the cosmic microwave background, the afterglow of the Big Bang. Our measurements are limited by light speed and cosmic history, so infinity might always remain a hypothesis, a profound, elegant, terrifying possibility. But here's the final thought. If the universe truly has no edge, then there is no final frontier. Exploration has no ultimate boundary. There is always more. More galaxies, more space, more unknown. No cosmic wall, no ultimate end. Just endless existence stretching beyond comprehension. And somewhere out there, perhaps infinitely far away, another civilization is looking into their sky, asking the exact same question. Does the universe ever end? Welcome to the infinite cosmos.